In this screencast, we're going to look at thermochemistry and its effect on energy and heat, the signs that indicate what direction the energy is flowing, state function, and how the energy flows in as a general rule. All right, we are focused on energy, so we probably should define what energy is. Energy is the capacity to do work or produce heat. Okay, so if you think about it, when you eat food, you are getting energy, and that energy is translated in your body to keep it warm or cool, or to have you do things, which is in technically doing work. So you are able to lift the pencil or push the books or walk, and that is in the form of work. And the heat that your body is, your systems are keeping yourself warm or cold, that's the heat. And that all comes from the energy in the food that we ate. The thing about energy is that energy will always flow from hot to cool or cold. So if you look at the graphic on this slide, you see red over here on the left, and you see the blue over here on the right. So we are always going to flow from red to blue, or from hot to cold. Okay, you will never see energy flow cold to hot. Cold is the lack of heat, so you will have the heat transfer to the cold situation and warm it up. All right, the words endothermic and exothermic describe the flow of the heat. And if you think back to your root word quizzes, you've probably seen endo and exo. In fact, you may have even seen thermic before. Thermic is talking about the heat. Okay? Endo is in to, and exo is exit. Okay? So in an endothermic reaction, we're talking about heat going into the reaction. And in an exothermic reaction, we're talking about heat exiting the reaction. So if we have our reaction, and it's in this circle, an endothermic reaction would go in, and an exothermic reaction would leave. One additional feature about endo and exothermic reactions: when the heat is going into the reaction or coming out of the reaction, they both have different signs. And the signs are not talking about how big or little the value is, it's just talking about which direction the energy is flowing. So if you have an exothermic reaction, you have a negative sign. And if you have an endothermic reaction, you have a positive sign. So all heat or all energy that is transferred into a reaction will have a positive value, and all energy that is transferred out of a reaction will have a negative value. If you look at these two very crude pictures, you have a fire and we have an ice cube. In the fire is labeled as exothermic. If you think about it, you can put your hands up near the fire and you can feel the heat. You can feel the heat being given off, and that would be exiting. So if we can feel the heat being given off and the energy is exiting the reaction of the fire, the overall sign is negative. Okay, if you have an ice cube and it is labeled as endothermic, this one feels cold. Sorry, not feet. Back that up. Feels cold. And what is happening here is that when you feel an ice cube isn't cold. It feels cold because it is absorbing the heat from your hands. And so the heat is going from your hands into the ice cube, which causes it to melt. So the heat is going in to that reaction, and it is a positive sign. Okay, so think about it. The heat is not you don't feel cold, you feel a lack of heat. So the heat from your hands is being absorbed into this ice cube. The heat, and we'll show it as the red, from your hands is going into the ice cube, causing it to melt. It is transferring from a hot situation, which are your hands, into the ice cube, which is cold. The heat goes from the hot to the cold, and it goes into that reaction, and it causes it to be a positive sign. The term that you're going to need to be comfortable and understand is called state functions. State functions are only worried with the current conditions and not how you got there. Okay, so state functions is like this example. If we're starting down here and we want to end up here, it does not matter what pathway we took. We can go up this orange path, we can go across this green one, we can go up the yellow one. The end result is that we made it to our end point up here in the center. And we don't care about the pathway. The path is not important. And when you will see that mostly is when you are looking at things like the change in temperature or the change in energy. We're just looking at the resulting value. And the change in, if you consider the change in temperature, the initial and the final are specific values, and it doesn't matter what the temperatures are in between, whether it's high or low or a couple of highs and a couple of lows. The same with energy. You're just looking at the final and the initial.